Thin layer chromatography, or TLC, can be used to identify compounds, assess qualitative purity, and monitor the progress of reactions. This is a TLC plate. It's a thin layer of silica gel adhered to a glass, or in this case plastic, backing. To prepare a TLC plate, use a pencil to mark a line on the silica side of the plate, about 1 centimeter from the bottom. Add a tick mark for each sample that will be run on the plate. Your samples should be prepared as dilute solutions in a volatile solvent. A capillary tube is used to spot just a few microliters of sample solution onto the plate. Don't confuse TLC tubes with melting point tubes. The tubes used for TLC are open on both ends. Place one end of the tube into the sample solution. Capillary action will pull up a few microliters. Holding the tube like a pencil, lightly tap it on the tick mark. Holding the tube to the plate will produce a spot that is too large. Let the initial spot dry and tap again to load more sample. Since many compounds are colorless, observe the plate under UV light to visualize them. This spot is too large. This spot is too concentrated. This spot is just right. A TLC chamber is constructed from a tall, flat-bottomed container, usually a beaker or a jar. Sometimes a piece of filter paper is added. The eluent is some solvent or combination of solvents that will run up the plate and carry the spots with it. Pipette a few milliliters of eluent into the chamber. If filter paper is used, saturate it with eluent. Hold your plate next to the chamber and ensure the level of eluent falls below the line you spotted your samples on. Use forceps to transfer the plate into the chamber. Make sure the plate is perpendicular to the eluent and try to keep it upright. Place a cap or watch glass on top of the chamber. This, combined with the filter paper, keeps the chamber saturated with solvent vapors. This can help the plate run more smoothly. You should be able to observe the eluent as it runs up the plate. The top edge is referred to as the solvent front. The plate may take a few minutes to run, but it's important that the solvent front doesn't reach the top of the plate. Once the solvent front gets within 1 centimeter of the top edge, remove the plate and immediately draw a line with pencil to indicate how far the solvent front traveled. Use UV light to visualize the spots and circle them with a pencil. The silica gel itself is polar, so polar compounds adsorb to it more strongly than nonpolar compounds. Therefore, spots that didn't travel very far on the plate are more polar than spots that traveled further. The eluent also influences how far compounds travel on the plate. Different combinations and ratios of solvents may be used depending on the compounds. Using a ruler, note the distance from the starting line to the center of each spot, and the distance from the starting line to the solvent front. This information is used to calculate the RF value of each spot. The RF value is the distance each spot traveled divided by the distance the solvent front traveled. The RF value is unique to each compound and should be the same when the same eluent is used. Sketch the plate in your notebook and include your measurements. Once recorded, the plate and capillaries can be disposed of in the broken glass box. The eluent can be dumped in organic waste and the chamber left to dry in a fume hood. TLC is one of the fastest analytical methods and doesn't require any instrumentation. Because of these advantages, it can often be run during a reaction or purification. When a pure product is spotted on a TLC plate for comparison, it can help determine when a reaction is finished or if a purification was successful.